Did you know that one of the biggest causes of climate change is climate change itself? It may sound strange, but as the Earth's surface temperature has gotten warmer, natural feedback loops have been set into motion that are making climate change worse, even without additional human interference. How do we know this is happening? Well, in the past few decades, scientists have noticed something peculiar. Although the Earth's surface temperature has risen by 1 degree Celsius on average, the Arctic Circle is warming at least twice as fast as the rest of the world. In fact, in June of 2020, Siberia, which is normally one of the coldest places on the planet, experienced a record-breaking heat wave, with temperatures reaching 38 degrees Celsius, or over 100 degrees Fahrenheit. This accelerated warming is due to a phenomenon called Arctic amplification, and is the result of many natural self-reinforcing feedback loops. Let's take a closer look at some of these loops and see how they exacerbate the impact of climate change at the Arctic Circle. The first feedback loop is probably the one you'll hear about most often. It revolves around the albedo effect. Albedo is a measure of how much of the sun's radiation is reflected back towards space from Earth's surfaces. Different surfaces have different reflective properties. White areas like snow-covered land and floating sea ice reflect the sun's radiation. Dark areas, like the ocean water, absorb the sun's radiation and heat up. Due to man-made climate change, some of the white ice in the Arctic Circle has melted. With less ice present, more of the sun's rays are absorbed by the dark water, causing the ocean to heat up and more ice to melt. As you can see, this loop reinforces itself, accelerating the consequences of warming in the Arctic Circle. Another problematic feedback loop is the melting permafrost. Permafrost is a thick underground layer of frozen soil, rock, and dead organic matter that has remained completely frozen for at least 2 years straight. However, as the Earth's surface temperature has been increasing, the permafrost has been melting. The organic matter in the soil begins to thaw out and decay. Millions of soil-dwelling microbes metabolize the organic matter and release carbon dioxide and methane into the air as a byproduct. These greenhouse gases contribute further to the warming in the Arctic Circle, causing more permafrost to melt in another self-reinforcing loop. One more factor that contributes to Arctic amplification are ocean currents. One of the major currents in the Arctic, the Beaufort Gyre, rotates clockwise and collects fresh water from glacier melts, rivers, and rain. This cold, fresh water stays at the surface of the ocean, protecting floating sea ice from the warmer, more dense salt water that comes into the Arctic Circle from the Pacific Ocean. Normally, every 5 to 7 years, the Beaufort Gyre reverses its direction, releasing some of the fresh, cold water into the Atlantic Ocean. However, due to climate change, an excessive amount of cold, fresh water from melting sea ice and glaciers has been accumulating in the Beaufort Gyre. This has caused the gyre to grow larger, spin faster, and be more turbulent than normal. This mixes up the warm and cold water, leading to further ice melt. What's even more worrisome is that the current has not changed direction in almost 20 years, meaning that the excess water is trapped. Scientists know that this cycle cannot continue. They fear that when the current does change direction, the excess cold water could be expelled all at once, causing a cold wave in the eastern part of North America and Europe that will affect everything from agriculture to fishing. Meanwhile, without the influx of cold, fresh water from the Arctic, ocean currents around the world are slowing down and getting warmer. One very important thing to note is that climate change seems to be having a very different effect at the opposite end of the world, in Antarctica. Remember, the Arctic Circle and Antarctica are two vastly different and unique environments. While the Arctic Circle is mostly ocean surrounded by land, Antarctica is land surrounded by ocean. Similar to the Arctic Circle, scientists have observed a decrease in Antarctic land ice, like glaciers and ice shelves, but they have also noticed an increase in floating sea ice. This may have to do with increased precipitation and wind at the South Pole, since the air blown in from the equator is warmer and consequently holds more water vapor. Also, as the land ice melts, excess fresh water is being dumped into the surrounding ocean, which freezes easily into sea ice. Overall, though, the world is still losing ice. The increase in sea ice in Antarctica does not balance out the amount being lost from both poles. Arctic amplification is just one example of why our climate goals need to go beyond transitioning to renewable energy. Even if humans magically stopped emitting all greenhouse gases right this minute, scientific models predict that Arctic ice would continue to melt due to the many feedback loops that are already in motion. Therefore, to truly solve the climate change crisis, we also need to invest in carbon capture and sequestration efforts. These technologies will allow us to remove the carbon dioxide that is already in the air, and hopefully help us break the feedback loops of climate change.